Hey televisions, back with me again, Ajika Utama Putrada. I am your lecturer for Parallel and Distributive Systems. This is our 11th meeting. We are discussing about shared memory model or thread. In the third video, we are going to discuss about sleep. So in the last video, we have created a very simple program of multi-threading, and we use Python, and we use the library threading in Python. And we executed the program, and the result is this is 1 and this is 2. Why is it this is 1 and this is 2? Because the function here prints this is percent %s, and percent %s is taken from num, and num is the argument of the function, and the argument is filled here when we created the thread. So t1 will have this is 1, this is 1, and t2 will have this is 2. This is 2. And the question is, which program ran first? Was it T1 or was it T2? The answer is because this is threading, and threading happens simultaneously or at the same time. T1 and T2 happens at the same time, but it can't be printed at the same time because eventually one of them will print first. And to show that T1 and T2 are running simultaneously, we have to make the program run longer. So here we are going to create a longer program. So the first step is to add while. So here we added a while. Where is the while? Here it is. We added a while, and we lose the return because it won't end. Why won't it end? Because here we added while 1, and 1 means true, and while true means it is always right, and because it's always right, the thread will loop forever. So this thread will loop forever, but it is dangerous if you just write it like this, because there will be no delay. So to have a delay, we need to add sleep. So to make the loop become longer, we add sleep. Before we can add sleep, we need to add library that uses sleep, which is called time. So here we need to import time, and then after we have printed this is percent %s, we call time.sleep here, and 1, this is in seconds, so 1 means 1 second. If you want to add, make it 2 seconds or anything else, you can do so. And now this is finished, and we will execute the program. And this is the result of executing the program. Here we can see it runs forever, and it interchanges between 1 and 2, meaning that thread 1 and thread 2 are running at the same time, but printing different things interchangeably. But here you can accuse of the program just being a program that's looping 1 and 2 forever. How do we know that they are running at the same time, not 1 and then 2 and then 1 and then 2? So to make a thing to show that 2 can run before 1, we will add a random variable. So here we are adding a random number, and to add a random number you need to add another library called random. So here we are importing random, and to create a random variable inside the loop we need to declare a variable outside the loop. So here we just write x equals 0 to declare a variable, and then here we call the variable with x equals random dot rand int, and 1 and 5 is the value that needs to be random, so it generates a value between 1 and 5, and then we use this random variable inside the time.sleep. So now the loop doesn't sleep for 1 second, it loops for a random number between 1 and 5, and by that we guess that thread 1 can run first, and then thread 2 can run second, or it can be the way around, just based on which sleep is longer or shorter. So now we are going to run the program. Now here we can see when we run the program, here for example 1 can print twice without 2 printing, because 2 is sleeping for a longer time, and also 2 can print twice without 1 printing, because 1 is sleeping for a longer time. So this shows that 2 and 1 are running at the same time, and it doesn't matter which one is started first, because they will run at the same time, and when they are sleeping anything can happen. So that's our conclusion of this video. So that is the end of video 3. In this video we have implemented sleep, and we have shown that thread 1 and thread 2 are running at the same time. In the next video we will learn about more about threads. Don't go anywhere. Thank you for your attention.